Okay, assalamu alaikum guys. Welcome back. This is Abdi Muhammad who will be taking for you chemistry of form 3 for information. Our topic on discussion today will be the empirical formula for information. So the empirical formula shows the simplest whole number ratio in which atoms combine to form what you normally call the compound. So it shows the simplest whole number ratio in which atoms combine to form the compound, okay? From the combo period. So the empirical formula shows the simplest whole number ratio in which atoms combine to form the compound. Remember, basically the empirical formula is more of calculation, okay? And we're going to see more examples so that you understand better this thing. By the way, the empirical formula will also lead to what you normally call the molecular formula. The molecular formula and the empirical formula have got some relationship, and therefore we are going to discuss first the empirical formula, then move to the molecular formula for information. To start with, basically we have calculations that involves calculating the empirical formula of a certain elements, okay? Let's see that. So let's see the first example. This is our example 1. We are told an oxide of silicon was found. An oxide of silicon was found. An oxide of silicon was found to contain 47% by mass silicon. Full stop. We are told what is the empirical formula of the oxide. What is the empirical formula of the oxide? Question mark. Now you are told an oxide of silicon, that is silicon dioxide, okay? Okay, or silicon oxide. So we don't know the oxide, so we want to get that. Remember, these are the elements. So this is what you're going to do. Remember this coming to the solution part. We will have first elements here. Just understand this. The elements are what? Silicon, which is abbreviated as Si. Look at this one. Si. Remember the S is capital. Don't forget that. And what? Oxygen. Oh. So you're told 47% is what? Is for this is the percentage composition, okay? The percentage composition. So this will be 47%. So if this is 47, remember 47 less 100 will give us what? Will give us actually 53, okay? That will be 53, of course. That will be 53. Then after that, we know that they said, remember, they said in the bracket here we have Si is equal to silicon 28, comma, or is equal to 16, or is equal to 16, or is equal to 16. So what we're going to do is actually, and we will use this one. So we're going to say mass, okay? Mass here is 28, and this is 16. So we're going to get what? We are going to get what we normally call an moles, number of moles. Okay, moles. Moles is actually, for us to get the moles, what we're going to do is we will divide this one by this one. Okay, we will divide this one by this one. So we're going to say 47. Look here, 47 divided by 28. Here also, we are going to say 53 divided by 16. So we are going to get our calculator to solve this problem, okay? So we are going to say 47 divided by 28, and we want to get our calculator and solve that for your information, guys. We will have our calculator here with us. This is what we are going to do. So 47 divided by 47 divided by 28 will give us what? Will give us, this is 1.6786. So let me write it here. 1.6786. Then 53 divided by 53 divided by 16 will give us what? That will give us 3.3125. So we're going to write then mole ratio. Mole ratio. This is what you're going to write. Mole ratio. Your mole ratio will be divided here by 1.6786. Okay? Divided by 1.6786. Obviously here you're going to get 1. But divided by 1.6786, it will give us what? 1.97. So this will give us roughly 2. So this is what you're going to write, remember? Therefore, we are going to say, therefore, the empirical formula is, you write SI, or then this will carry 2. Because when you run off, that will be the final answer for your information. So this is how you're going to calculate. You are told these are the elements, silicon and oxygen, because you're told silicon oxide, yeah, an oxide of silicon. So you are given the percentage composition of what? Of silicon. Remember, the percentage composition of silicon plus that of oxygen must give us what? 100. So if you have 47, to get the percentage of oxygen, you're going to say 100 minus what? 47. Then that will give you what? 53. Then you have the masses. They will give you this thing in bracket. So mass of silicon is what? 28. Because silicon is 14, atomium 14 times 2 is what? 28. Oxygen is 16. 8 times 2. Okay? Then after that, you're going to get moles. Moles is this divided by this one. Okay? This will give us what? 1.6786. Okay? 786. Then 53 divided by 16 is what? 3.315. So between these two now, which one is smaller? This one is smaller, 1.6786 and 3.3125. This one is smaller, so you're going to divide both sides by this one. Then obviously here you're going to get 1. This divided by this, it will be 1.97. So the moment you reach here, if you realize that what's coming after the decimal is a number which is greater than 5 and it's not 5, then you run off, remember. But if it's 0.5, then you multiply by 2. So this one rounded off to the nearest number, it will be 2 now. So this 2 is for oxygen and this one is for silicon. Therefore you're going to say the empirical formula is what? Is actually what? Is SI then O2. SiO2, and that's what you're going to do for your information. Guys, let's see the second example. Let's see our second example, okay? Let us see example 2. Let us see our example 2. Let us see the second example. Let's see the second example here. Okay, we'll go and see second example. You're told, look here, the percentage example 2. This will be our example 2. So you're told the percentage composition by mass. The percentage composition by mass. The percentage composition by mass of an oxide of iron is 70% iron, 70% what? Iron, okay, and 30% oxygen, and 30% oxygen. Remember this is 30% oxygen. Okay, full stop. Determine its empirical formula. You're told determine it is empirical formula. Okay, full stop. Then you're told in the bracket we have iron is equal to 56, oxygen is equal to 16 in the bracket. So this is very easy. So what are the elements? Solution to this problem. Okay, we have the elements. Our elements are what? Are iron and oxygen. So we have their percentage composition. Iron is what? 70%, while oxygen is 30. So we are going to write mass of this element, yeah? Masses of this element. So we're going to say mass is equal to iron is what? Look at 56 right in front of that, and this is 16. Then you're going to write what you normally call moles. Moles is what? This divided by this. That will be 70 divided by 56, and that divided by 16. So let's say 70 divided by 56. That will give me, this one will give me 1.25. Okay, let me see also this one. That divided by 16. Let's also see this one. This is 1.875. Okay, so which one is bigger? Which one is smaller between these two? This one. Divide both sides by this one. 1.25. 1.25. So obviously here you're going to get what? You're going to get 1. Let's see there. Okay, our answer divided by 1.25. So that will give me 1.5. But from here I've gotten what? 1.5. Look at this point now. Here we have gotten 1.5. Okay, so now you cannot run off. The moment you have 0.5, say 10 is 2 here, 10 is also 2 here. So that will give us what? Here 2, there 3. So what are you going to say? You're going to say therefore, the empirical formula is write iron and oxygen. Then iron will get 2 and oxygen 3. So that will be the final answer for your information. Then we go to our next example, okay? Example 3. Please just understand, this is very, very easy by the way. So you just understand, yeah? Then these are the questions from the KP, as you can see. Then now we can tackle questions from KCAC. Okay? Questions from where? From KCAC for your information. Okay? Let's go and see the main familiar now. Okay? Let's go and see the main familiar questions. Okay? Let's see example 3. Let's check our example 3. Just understand, this question is very easy. Then we go back to this question. You are told the percentage composition by mass of an oxide of iron is 70%. Okay? Iron, and 30% what? Oxygen. So you're told determine it is empirical formula. In bracket, iron is what? 56, and oxygen is what? 16. So you're going to say elements. What are these elements you're having? You have iron and what? Oxygen. Right, elements, iron and oxygen. Percentage composition 70 and what? 30. Then mass is what? 56 here. Yeah, iron is 56 and oxygen is 16. Get moles here. Get moles. So this is what you normally call down there. We will have what? Mole ratios. Mole ratios. This is what you normally call the mole ratios, 1 and 1.5. After dividing these two, yeah. After dividing between these two, there is smallest one, both sides, okay? Then after that, after you get now 1.5 and 1.25 and 1.875, between these two, this one is small, you divide both sides by this one, then here you're going to get 1, but here we've gotten what? 1.5. The moment you get 0.5 times 2 times 2, yeah, then this will give us 3 and this is 2, then from there you're going to get that one as your empirical formula. Okay, let's go and see this one. So you can go now to and see this one. Let us see this one. It was there in KCSE, remember? So we have to solve KCSE questions. So you understand better this thing, okay? You must solve KCSE questions so that you understand better everything. Okay? You must take advantage of these commercial books because questions are French. Just like the one of KCSE, because all these questions are from KCSE, remember? Okay? Look at this question. You're told this will be an example 3. Example 3, you're told when a hydrocarbon was completely burned. Was completely burned in oxygen. Comma. You're told 4.2 gram of carbon dioxide and 1.7 and 1.71 gram of water were formed. First of all, determine the empirical formula. Of the hydrocarbon. Full stop. Then you're told in the bracket we have H is equal to 1 comma, or is equal, carbon is equal to 12, oxygen is equal to 16, carbon is equal to 12. So remember we see the hydrocarbon. Hydrocarbon is a compound that is made up of what? Carbon and hydrogen only. So oxygen will never be part of this calculation, remember. And we said, remember, be very keen here. We said, for your information guys, we said, for us to calculate this one, you must have what? Elements. But here we are told when hydrocarbon was completely burned in oxygen, you are told 4.2 gram of carbon dioxide and 1.71 gram of water was formed, determining the empirical formula of the hydrocarbon. So the masses of carbon and hydrogen, we are going to say like this. Remember, solution to this problem. The masses of carbon and hydrogen, remember, in carbon dioxide and water formed is what you're going to get. Remember we said we want to get carbon. Remember the mass we have is what? Carbon is what? Atomic number 12. So we can say, let's say these are the elements. For carbon now, let's say elements. We have what? Carbon and what? And hydrogen. So carbon, remember carbon is what? 12. Because here, we are told, look here, you are told when hydrocarbon was completely burned in oxygen, 4.2 gram of carbon dioxide. And so this 4.2 is for carbon dioxide. But we must get the mass of carbon itself. So carbon is what? 12. It has 12. Okay? 12 all over total. Carbon dioxide is what? Carbon dioxide is written like this. CO2, that is 12 plus 16 times 2, that 2. So that's 44 times, you're going to say 4.2. So its mass will be how much? We're going to say, remember, 12 times 4.2 divided by 44. That's 1.145. This one we have gotten 1.1, 1.145. What about this one? Hydrogen is 2 here. So hydrogen is 2 over total. Remember the total of water is what? 16 plus 2 is 18 times also the mass of water formed. Okay, that is 1.71. Okay, so that will give us how much? 1.71 times 2 divided by 18. Okay, so that is 0.19. So okay, from there now, what are you going to do? These are the masses. Okay, you're going to solve by seeing like this. Look here. Okay, what are we going to do then? This is what we'll be doing now. We want to get the lump of moles. Remember, mass. The mass of carbon is what? Is 12, and this hydrogen is what? 1. So let me get moles. Moles will be how much? 1.145 divided by 12 here. 0.19 divided by 1. So let's say 1.145 divided by 12. So that is what? 0.095. Then 4. This is 0.19. So this is the simplest one. So you're going to say 0.0954, 0.0954. Obviously here we're going to get 1. So let's say 0.19 divided by our final answer. So this one I've gotten 1.99, which is roughly 2. We run off. Okay, we're going to run off this one. Okay, so we're going to say therefore the empirical formula is CH2. Okay, CH2, because you're going to multiply C by 1, so it will be C. It will remain what? C. Okay, CH2. So that's how you're going to calculate. Look here, let me make you to understand this thing. Huh? You are told when a hydrocarbon was completely burned in oxygen, 4.2 gram of carbon dioxide, not carbon, yeah? Carbon dioxide, and 1.71 gram of water, not hydrogen again, were formed. Determine the empirical formula of the hydrocarbon. Remember, a hydrocarbon is a compound that's made up of what? Carbon and hydrogen only. So we cannot take carbon dioxide. So we're going to say the masses of carbon and hydrogen in carbon dioxide and what you normally call water formed. So I want to get carbon dioxide, the mass of carbon dioxide from total mass. Sorry, the mass of carbon from the total mass of carbon dioxide. That would be carbon is 12 divided by total, which is 44. 44 is from where? 12, which is carbon, plus 16 times 2. Okay, that's the 2 plus 12 is how much? 44, yeah? Times the total mass of carbon dioxide formed. So that would give us 1.145. Then for hydrogen, here in water, hydrogen is what? 2. Hydrogen is 1 times 2 is what? 2. Divided by total, which is the mass of water, which is 18, multiplied by the mass of water formed, which is actually 1.71. Then from there we're going to get 0.19. So between these two now, this one is the smallest, yeah? This one is smaller than this one, not the smallest. This one is smaller than this one, so I will divide both sides by this one. Okay? Now before I proceed in that, then I will say masses. The mass of carbon is 12 and that of hydrogen is 1. So you divide this one by this one and this one by this one. Then 1.145 divided by 12, it will give us 0.0954. 0.19 divided by 1, it will remain the same. So between these two now, this one is smaller than this one. So divide both sides by 0.0954. Then we are going to get 1.99 and 1 here. So this one we are going to run off because it's not 0.5 by the way. So we are going to run off information. So this is how you are going to get the empirical formula of a carbon, okay? And it is very, very easy by the way. In our next class, we're going to discuss, guys, the molecular formula. Make sure you subscribe our YouTube channel because it will help you, and share with your friends and family members. Otherwise, I wish you the best.